Welcome to the UChem tutorial on using the periodic table part 2. In this video, what I will do is explain some of the major subdivisions of the periodic table in its organization. It would be really helpful if you had a periodic table in front of you, especially one that you can draw on, because what I'm going to be doing is drawing on the periodic table to give you these divisions and categories, and it'd be helpful if you could follow along with me. What I'm going to do first is just strip everything off the periodic table and look at its structure by taking a look at the division between metals, nonmetals, and metalloids. Every time I look at an element on the periodic table or I think about an element, I always think about whether it's a metal, a nonmetal, or a metalloid. And the reason why I want to do that is because metals, nonmetals, and metalloids have distinct properties, distinct characteristics, and distinct behaviors when they act with other elements. So what we'll need is this stair step. Okay. And the stair step on the periodic table starts up at boron and steps its way down to astatine, or if you want to climb your way up the stair step, you start at A for AT or A for astatine and you climb to B. So one or the other, what you want to do is locate that step or that division on the table. And then what you want to do is look to the left of that step, and what you'll find are the metals. A majority of the elements on the table are metals, and you'll find all of them on the left side of the periodic table with one tiny exception, and I'll come back to that in a second. On the right of that stair step, you'll find the nonmetals, and the nonmetals, are very important as well, but there are just fewer of them. Okay. Now, touching the stair step, and I'm coloring this in this little lilac color, okay, are the metalloids. So the metalloids touch the stair step. Not every element touching the stair step is a metalloid. And so what you need to do is just take a look at a periodic table colored in for that. You'll see the little exceptions that are there. And so what you're going to look for are those elements that usually the ones touching the stair step are the ones that are the metalloids. Okay, the metalloids have properties between metals and nonmetals. They're kind of in the middle there. And so you can see them on that border line as they touch that little division on the periodic table. Okay, so now that we know what major categories elements fall into, now let's take a little deeper look at the organization of the periodic table. So groups are those columns on the periodic table, and the columns on the periodic table contain elements with similar properties. So what I want to do is first show you where those columns are, and then I'm going to highlight some very important groups on the periodic table. So those numbers that I've just drawn across there, 1 through 18, are the numbers that are associated with each column or each group, and those numbers will just march you from left to right across the table. So we have 18 columns on the periodic table, and those are labeled 1 through 18. So now, let's take a look at our first column. Our first column is over in the metals. All right, we're on the left of that stair step, and these are the alkali metals. These metals form +1 ions. There's a reason for this, and we'll get to that later on when we start talking more about atomic structure, but for now you can remember that group 1 on the periodic table forms +1 ions, and all of these are metals with one very notable exception. And I said before there's a little exception here, and that little exception is the smallest element, hydrogen. And so that small element hydrogen is found in period 1 and group 1, the very first square, and this is an element that forms +1 ions, so it kind of falls into that group of alkali metals, but it is a non-metal. Now, our next column, are these alkaline earth metals. These form +2 ions, and you'll find them in group 2. Now, our next big group are all those elements in that little shorter area of the periodic table. These are the transition metals. And transition metals, starting there, you can have elements that can have varied states. So meaning that they can have varied charges on them, varied charged states. And so just be careful with these guys. They don't have a set charge that the metals can form. Some of them have multiple charges that they can have, and an example would be iron, which can have a +2 or a +3 charge. So just be careful with those transition metals. You will probably have to memorize the common metals that have multiple charges. Most of those are found within the transition metals. There are a couple in just under that stair step in the just to the right of the transition metals, but for a lot of them, they're within the transition metals. These are metals that can have many charged states. All right, so let's take a look at one other group here. These are the halogens. These form -1 ions. These are non-metals. So if you notice, we've looked at the metals. All those metals are forming cations or plus charged, positively charged ions. And the non-metals found to the right of that stair step, these form negatively charged ions. And a main group of these are the halogens, and you'll find them in group 17 there on the table. And then next door to the halogens, these are the noble gases. Put a little crown there for these, the most noble of elements. That is because these actually don't form ionic compounds. They don't form charged species very often. They often don't form compounds at all. They like to be on their own, like the nobility. So we call these the noble gases. And we'll talk quite a bit about elements wanting to have the structure of a noble gas. So we can say that all the other elements on the periodic table are very jealous of those over there on the very, very right, those noble gases, and they try to be like them when they form compounds. So we'll talk quite a bit about the noble gases as we talk about atomic structure. Now there's one other area of the periodic table I want to talk about, and it's actually not a column. It is actually another group, and what I mean by group here is I mean a assembly or assemblage of elements, and those are that little boxes that you see that set down here on the bottom. These are the lanthanides and actinides, and these are elements that really should be in the main area of the periodic table, but we've dropped them below. They belong right there. And they're called sometimes inner transition metals as well, or rare earth metals. And they're inserted, if you look on the periodic table, there's a discontinuity in the atomic numbers. You'll be counting along and all of a sudden, oh, they skipped some. And that's because we've moved those rows down, pieces of them down underneath the table. And because these elements have properties that are all in common, and we can kind of take them down below the periodic table, it makes the table a little less long and wide. It makes it easier to fit on a page as well. So these are not a group in terms of the column on the table, but they are a group as a group of elements that we've moved below the periodic table. All right, so we have one other thing about the periodic table we have to talk about, and to do that, I gotta wipe it off a little bit. And what I want to do now is, instead of talk about groups, I want to talk about periods, because this is the periodic table. And the periodic table, the periods on the table are the rows. And the rows have repeating properties by row. So what you'll see is if you move across a row, you'll see similar properties repeating over and over again. So to illustrate this, what I'm going to do is show you, recolor in my groups. All right, and if you see, I've numbered 1 through 7 down the rows of the periodic table. And what you do is you take a look at moving across a row. And I'm going to move across row number 4, or period 4. And as I go through period 4, I'm going to pass through the alkali metals, the alkali earth metals. Now I'm in the transition metals. And as I move across the periodic table like that, and I'm moving across the transition metals, and I've gone into the halogens and over to the noble gases, and then I've done that again. And I've gone in row 5 and I've done the same thing again. And as you move across the periodic table in rows, what you're going to see is repeating properties. So in row 4, I went through the same types of elements as I went through in row 5. If I were to go through row 6 and row 7, I would have done the same thing. So the periodic table is arranged by order of atomic number, and the same properties repeat row after row. Okay, so this analysis of the periodic table, kind of by taking away all the names of the elements and just looking at its structure, gives you a better idea of how to use the periodic table. And please make sure that you understand the difference between groups and periods, because they do represent different properties for an element.